Hello everyone. My name is Bhumi Shivhare, and in this presentation, I'll be walking you through how I built a Flutter-based controller application for the Liquid Galaxy system. This work is a part of the Liquid Galaxy GSOC streaming prerequisites, and also the main idea here is not just to show you a UI, but to explain how a controller system is structured and how the mobile app talks to Liquid Galaxy and how commands flow through the system and how the architecture is designed to be scalable and safe. So throughout this session, I'll cover the overall architecture, controller logic, SSH communication, and the executing pipeline that connects the Flutter app with the Liquid Galaxy rig. So let's start by understanding how the application itself is structured. Okay, so this slide shows the high-level architecture of the application. At the top, we have the UI layer. This is basically the home screen where the user interacts, buttons, controls, inputs, and or visual elements. They all just live here. Now, one important design decision I made was that the UI should not directly communicate with Liquid Galaxy. Instead, what I tried to did was like every action from the UI goes through this central component here called LG controller. Okay, so you can think of LG controller as the main control hub of the app, where the user clicks something, then request first comes here, and from the point LG controller decides what type of operation needs to happen. Like if it's related to remote execution, the request is passed to SSH controller. Yeah, you can see the SSH controller here. And if it's related to configuration, then the request interacts with the settings controller. So the SSH controller handles all communication, all remote communication things like sending commands over SSH, settings controller, and manages persistent configuration such as host address, port number, and safe credentials. So the overall idea is very intentional. UI handles interaction, LG controller handles coordination, and settings controller handles the configuration. So this separation makes the system easier to maintain, easier to debug, and much easier to extend when new Liquid Galaxy features are added. Let's move forward. Now let's look at what actually happens when the app starts. Everything begins from the main function. This is the entry point of every Flutter application. From here, the initial setup process starts. Okay, so now this is my initialization. After that, like the core controllers are initialized. Setting controllers, SSH controller, LG controller, like it loads previously first I'll talk about the setting controller. So setting controller loads previously saved configuration values such as host and port, and SSH controller prepares the network communication layer for the basic communication like what we want to do, and the LG controller connects everything together so it can coordinate future actions. And moving to the provider scope, like provider scope is used for dependency injection. What this means is, like, dependency injection sounds like a huge word, right? So what this means is that all these controllers become accessible across the tree without manually passing objects around. This keeps the code clean and avoid tight coupling between UI and backend logic. And finally, home screen is rendered, and at this point the UI becomes active and user interaction can begin. So open the code. Let's move to so here is our main dot. We'll open it and see. If we look at the code, the flow is implemented inside main dot. You can see the app is wrapped with provider scope. You will see it here. Yes, the whole app is wrapped under this provider scope. And controllers are initialized: SSH controller, settings controller, LG controller, right? And the home screen is loaded. Here you can see, yeah, the home screen is also loaded as the root widget. This ensures that the UI is only rendered after all dependencies are ready, which avoids runtime errors and inconsistent states. Right, so let's move back to our presentation. Yeah, moving to next slide. Yeah, now let's look at what happens when the user actually interacts with the app. So when a user taps a button on the home screen, the UI does not execute system logic directly. Instead, as I told you before, it forwards the action to LG controller. So this is a deliberate design choice that I made. Like, the UI layer remains focused only on presentation and interaction also, while the LG controller handles all the application logic. Once LG controller receives the request, it decides what needs to be done. For example, sending a KML file and refreshing the display, or triggering a navigation command. Then it calls the appropriate internal method to handle that specific operation. So the UI sends intent and the LG controller converts the intent into real system behavior. Let me also show you the code. Yeah, let's just go to the home screen and where are my buttons? Yeah, here. So yeah, as you can see here in the UI code, you'll notice that the buttons simply calls a controller method. Like, yeah, LG controller, these are all my buttons and they are calling the LG controller methods that are assigned to them. So yeah, moving back to the presentation, moving on to the next slide. Yeah, LG controller is the backbone of the application. So every major action passes through this controller. It coordinates command execution, KML handling, and also the screen logic. So instead of allowing the UI to directly manage system complexity, LG controller acts as a middle layer that keeps everything organized. This approach is very useful because it centralizes logic and avoids duplication across the UI layer. Another advantage of this design is extensibility. Like, let me just think. Yeah, so if I want to add a new Liquid Galaxy feature later, I only need to add a new method inside the LG controller. Like, the UI does not need that major changes. Once I'll just add it to LG controller, and yeah, it will connect everything together again. LG controller. Okay, so here you can see LG controller in the code base. Each method here represents a high-level Liquid Galaxy action. What I meant is, like, LG controller itself does not directly send SSH commands. Instead, it delegates the responsibility to SSH controller. This separation keeps business logic and network logic independent. You can see the SSH thing here, and yeah. So okay, so now moving on to the next slide, that is the LG controller to SSH execution pipeline. So this slide shows us like how commands travel from Flutter app to the Liquid Galaxy system. First, LG controller checks whether the system is connected or not. Like, if the connection is not active, the request is stopped immediately. And if everything is ready, the request is passed to SSH controller. SSH controller then sends commands securely to the LG Galaxy machine, like where the actual execution happens, such as loading KML files or controlling the camera movement. So the responsibilities are clearly separated. Like, LG controller handles decision making, SSH controllers handles remote transmission, and yeah, now moving on to the next, that is the SSH connection lifecycle. So this is a very important slide. This slide focuses mainly on how the SSH connection itself is managed safely. Like first, the app creates a timed SSH connection. This ensures that the app does not wait forever if the server is unreachable. And yeah, now this slide goes one level deeper into how the SSH session is actually managed internally. On the right side, you can see the connection lifecycle. The session always starts in a disconnected state. You can see it here. And when the user tries to connect, the app moves into the connecting state using the connect function, connect button. Okay, now if authentication and socket connection succeeded, the states become connected, and only then the app allows command execution. If something fails, for example, network timeout, wrong credentials, and host issues mainly, the session moves into an error state. From there, the app can either retry the connection or safely disconnect. This design prevents unstable or half-open connections from being used. So basically, every SSH connection in the app is guarded by this state flow. I'll just show you once. SSH controller. Yeah, here in the code you can see how this logic is implemented. Where is my try and catch function? Yeah, so first the socket connection is created with a timeout so the app does not wait forever. After that, the SSH client is initialized and the connection state is updated. If any socket exception occurs, the error is caught and converted into a readable message. Like instead of showing raw technical errors, the app maps them directly into the user-friendly feedback. So yeah, you can see here I'm trying, and if any error occurs, it will catch and return connection failed. Okay, switching back to the slide and moving to the next. So overall, this approach makes SSH communication safer, more predictable, and easier to debug also. Okay, remote command execution engine. Now, this slide explains how the app actually controls the Liquid Galaxy system at a technical level. The first part is remote command execution. The app uses the SSH interface to send shell commands directly to the Liquid Galaxy machine. Okay, so command output is captured and returned to the Flutter application. Okay, what does it mean is when a command is executed, the output is captured and written back into a Flutter application. This is useful because it allows the app to confirm whether the command was successful or if any error occurred. And about the SFTP protocol, like along with the command execution, the app also supports file transfer using the SFTP protocol. Okay, so why do we need a file transfer? Because like this is mainly used for sending KML files and related assets to the Liquid Galaxy system for the visualization. Okay, so one important design detail here is that both the command execution file and the file transfer happen within the same SSH session. This avoids opening multiple connections and keeps communication efficient. Okay, I'll also show you the my commands. So this is my SSH controller.dart, and I'll show you the execute command function. Yeah, so here you can see the execute command function. The command is sent using the SSH client that I created, and the result is captured, converted into a readable output, and then returned to the app. And okay, now that we have understood the commands, how commands and files are sent, let's move to the KML section. Okay, so for that we need to know about Liquid Galaxy control interfaces. Okay, so this explains how Liquid Galaxy actually receives and processes control instructions from external applications like our Flutter app. So Liquid Galaxy does not directly listen to mobile apps. Instead, it relies on few predefined system interfaces. The first important interface here is kml.txt loader, like which loads our KML files. And you can see it here. This file tells Liquid Galaxy which KML layer should be active. So when the app wants to display a visualization, it uploads the loader file with the required KML path. So here is the path. And next is the KML storage directory. This is where the actual KML files are uploaded using SFTP. So Liquid Galaxy reads files from this directory and renders them across the display cluster. Okay, so finally the navigation and camera movements are handled using the query interface. This interface allows the app to send dynamic camera commands like zoom, fly to, and rotation, all of that brilliant moves we can do on the Liquid Galaxy system. Okay, so overall the Flutter app does not directly control the screens. Instead, it writes instructions into these system interfaces and Liquid Galaxy continuously reads and applies them. Okay, so now that we have understood the entry points used by Liquid Galaxy, let's look at how KML refresh and loading is triggered from the app side. Moving to the KMLs now. Okay, so now this slide explains how visualization is actually controlled inside Liquid Galaxy using KML. KML, which stands for Keyhole Markup Language, is basically the format used by Liquid Galaxy to define what should appear on the screens. Things like camera positions, place mark, overlays, and guided tours. Okay, so in our app, the process starts with KML asset inside Flutter. When the user triggers a visualization, the app first uploads this KML and then it registers it into the correct path in the Liquid Galaxy system. Okay, after uploading, the file is registered inside the kml.txt loader. This step is important because Liquid Galaxy constantly reads this file to know which KML layer should be active. Okay, so once registration is done, the app triggers a refresh command. So this forces Liquid Galaxy to reload the updated KML and immediately apply the visualization changes. And finally, the updated visualization appears across the Liquid Galaxy screens. Oh, sorry. Yeah, so the app doesn't directly draw anything on the screens. Instead, it updates KML instructions and Liquid Galaxy interprets and renders them. So before moving ahead, let me quickly show you how a KML file actually looks when rendered. So I'll just open my KML file. Yeah, let's open KML1. Okay, so this is how an actual KML file looks like. So this is the preview of the same KML format that Liquid Galaxy consumes. Okay, so here you can see the camera positions, place mark, and everything defined inside the KML. So when the app uploads this file and triggers refresh, Liquid Galaxy renders the same structure. Okay, so KML handling pipeline. Now this slide shows the complete internal pipeline of how a KML file moves from the Flutter app all the way to Liquid Galaxy visualization screens. So this is basically the practical implementation of what we decided in the previous slide. Okay, so here in the first code block is transfer KML file from Flutter app to Liquid Galaxy server. Okay, so the process starts when the app uploads the KML file using the upload asset method, and thus transfer all the KML file from the mobile device to the Liquid Galaxy server directly using SFTP. And here in this code, you'll see like after the file is uploaded, the app updates the kml.txt loader file. This step registers the new KML file, so Liquid Galaxy knows this visualization should be activated. Oh, just a minute. Yeah. Okay. Then the refresh command comes into action and it triggers a refresh action. This forces Liquid Galaxy to reload the KML configuration and immediately apply a new visualization. And you can see also I have created this visualization control layer, and yeah, that's how it works. All of like everything I just said is inside this command flow. Okay, so as you can see, like this briefly explains everything visually. Like the Flutter device sends the KML data to the bridge server and the KML management layer process it, and finally the visualization screen render the updated content. So this pipeline fully automates the process from file transfer to visualization update without any manual intervention. Now that we understood how visualization content is handled, the next step is looking at how this system supports multi-screen control. So yeah, multi-screen and slave control logic. Now, this explains how the app handles multi-screen control in Liquid Galaxy. Liquid Galaxy is not a single display system. Like it's a cluster of synchronized screens. So controlling content across multiple displays requires special handling. So Liquid Galaxy uses separate KML files for each slave screen. This means the app cannot just send one visualization file and expect it to work everywhere. Instead, it generates and assigns specific screen KML files. The screen index is calculated dynamically based on the rig configuration, so like even if the number of screens changes, the logic still adapts automatically. Okay, so this approach allows targeted overlays, for example, showing slightly different content on each screen while still keeping everything synchronized. I'll also show you this screen logic calculation code. Well, it's here only, but still I would want you to see it. Okay, so this is my LG controller and my screen index calculation. It might be somewhere in my yeah, here you can see get logo screen. Like it basically calculates the number of the specific screen that we want to send our data to. Okay, now so this logic makes the system flexible and scalable for different Liquid Galaxy setups. Now that multi-screen handling is clear, let's move to how application configuration is managed and persisted. Okay, so settings, controller, configuration management layer. Okay, so now this focuses on the settings controller, which is basically responsible for handling all persistent configuration in the app. Without this layer, users would have to re-enter Liquid Galaxy connection details every time the app restarts, and we all know how it really feels, which is obviously not practical. So here the app loads saved values like host, port, username, password, and reconfiguration using shared preferences. Like if some value is missing, the controller automatically falls back to default value so the app can still start safely. So like the key of this controller is to centralize configuration management. LG controller simply requests configuration from here instead of directly handling storage logic. So this separation keeps the architecture clean. Oh, okay, so let me also show you like the code. Let's move to settings controller.dart, and this is my settings controller file, and move to the load settings function. Yeah, you can see here how values are saved and loaded for persistent storage, which ensures settings remain available across like whenever the app restarts. Also, here is the save settings. Yeah, it saves all your credentials like LG host, LG port, LG username, password, and rig number, so you don't have to enter it again and again whenever you want to have access to the app. Moving back to our slides. Yeah, okay, so yeah, now that we have seen how the setting controller works, this slide shows the full life cycle of how configuration is actually stored and reused across app launches. So what's happening here is pretty simple but very important. When the user enters Liquid Galaxy connection details like host, port, or rig configuration, the app saves them locally using shared preferences, as I told you before. Okay, so then when the app restarts, those values are automatically restored during startup. This means the user does not have to reconfigure everything again and again. Okay, I would want you to see this once more. Okay, so here you can see like this method, load settings method, is pulling saved values from local storage and providing fallback defaults if something is missing. Yeah, that's it. And now let's look at how the system handles runtime errors and recovery, because that's also important. Okay, so like when you're working with SSH networks and remote machines, failures are there. They are just normal. They are not exceptions. So what happens here is the app does not directly show raw SSH errors to the user. Instead, low-level exceptions are first intercepted, then categorized, and finally converted into readable messages. For example, if the connection is refused, or the host is unreachable, or authentication fails maybe, each case is mapped to a clear message that the user can actually understand and act on, instead of blindly assuming that something is happening. This helps user fix configuration issues faster, at the same time prevents the system from entering broken states. And yeah, I'll show you how these errors are controlled. We'll go to our SSH controller.dart. Okay, so as you can see here, you can see how different error patterns are checked and mapped to specific messages. This now it's time for the walkthrough, I guess, for the same flow, but this time I'll be using the actual app that I created, so you can see how everything comes together in practice. This is a Flutter control app UI. This is the home screen layer we talked about earlier, where I can interact with the UI. The request is not executed, it is forwarded to the LG controller. So these connection values were restored automatically from local storage, as I told you before, using the shared preferences, which is exactly what we saw like in the persistent configuration lifecycle. Check the KML flow now. For visualization updates, the app uploads KML file using SFTP registers, and then using the KML.txt loader, and triggers a refresh so the new content appears on the screen, as you can see. And if something fails here, for example, network issues or wrong credentials, the system does not crash silently. Errors are intercepted, categorized, and shown as readable messages to the users. Okay, so this is the complete end-to-end execution flow, from mobile interaction to secure remote execution and the real-time visualization updates. So everything you saw here directly maps to the architecture and design decisions explained earlier. Okay, first of all, thank you everyone. And to wrap this up, I'd just say that we designed a clean architecture, separated UI from control magic, and created a scalable controller layer that can grow with future features. And thank you for your time, and thank you to the Liquid Galaxy and GSOC teams for the opportunity to work on this project. And yeah, I'm happy to answer any questions.